Okay, so we're going to do the January 2011 Algebra 2 Trig Regents now. Which graph does not represent a function? For something to be a function, it's got to pass the vertical line test. This guy right here fails it. In other words, if you try and sweep a vertical line through, it'll hit in more than one spot. See that? 1, 2, 3 spots it would hit. The roots of the equation, anytime you're asked to find questions about the roots, or you see a multiple choice answer that looks like this, responses that look like this, use the discriminant. The discriminant is b squared minus 4ac. This number in front of x squared is a. This number right here is b, negative 10. And this number right here is c. Plug it in. See how you get 0? Okay. If you had gotten a negative number, the roots would have been imaginary. If you had gotten a random number that you could not take a square root of, the roots would have been real and irrational. If you got 0, you'd get real, rational, and equal. That's a real fancy way of saying also that there's just one root. And if you had gotten a number that you could take the square root of, like 4, like 16, like 9, like 25, then you get real, rational, and unequal. Okay. This equation, if you want to call it, is in the quadratic formula. This is the stuff underneath the square root. Which values of x are solutions of this thing? Well, here's what you do. You factor it. These guys all have x in common. You're left with, if you pull out the greatest common factor x, you get this. Factor that. Set them all equal to 0 and solve. You get 0, negative 2, and 1. Unit circle. Points on the unit circle are found by taking the cosine of theta corresponding to the x, the sine of theta corresponding to the y coordinates. And so all you do is just take your multiple choice answers, you plug them in, and you find whichever one gives you these two numbers. What's the 15th term of this sequence? What you do is, or at least what I did was I attempted to write it out. Okay, so I got 15 spots. I know what the first 5 are. How many times, or how do I get from spot to spot? Turns out we're multiplying by negative 2 to get from spot to spot. And so how many times will I need to multiply by negative 2? Well, that's what you count these arrows. 1, 2, 3, 4, 5, 6, 7. There's 14 arrows. Okay, so 5 times negative 2 to the 14th gives me that 15th term. That's 81,920. What's the solution set of this equation? This is just, honestly, you just plug your multiple choice answers in. It's easier than doing all the algebra. There is nothing. None of these answers work. 7, sine A is 2/3. A is between 0 and 90. What's the value of sine 2A? This is from the reference sheet. This converts into the following. You'll see it on there, sine 2A equal 2 sine A cos A. Okay. And so you know how much A is. They told you that. But you don't know how much cos A is, and that's a problem. That's where this piece of information comes in. Draw the triangle in this quadrant. Okay, everything's positive. Now, use Pythagorean theorem to find the missing side. Good. Now you know the cos of A. The cos of A is this adjacent side over the hypotenuse. And if you know the cos of A and you know the sine of A, you can plug into this formula and find the answer. Just multiply. This guy right here, it's a probability question. It tells you that the measure of the angle in sector 2 is 2 pi over 3, and I converted that into degrees. Remember, you convert from radians to degrees. A cheap shortcut is you can just sub 180 in for pi. Sub that and get 120. Okay. So now, there are 360 degrees to a circle. That's how much is allowed for all of these 4 angles added together. This guy right here is 120. We know that. This is a vertical angle to it, so it's also 120. That leaves me 120 degrees to split up between 1 and 3. And they are also vertical angles, so they could get split up evenly. So now, 120 degrees is how much angle 1 and angle 3 are worth. That, compared to the whole circle, gives me how much space both 1 and 3 take up together. So 120 degrees is to 360. A third of the circle is made up of basically of 1 and 3, and therefore there is a third of a chance of hitting 1 and 3 if you're throwing darts at it. 9. Compositions. Ooh. Take f of x, this amount right here, sub it into g of x, like I've done, right? F of x is worth x squared minus 5, so you can literally replace it with x squared minus 5. And that means you can replace this thing right over here, this x, with x squared minus 5. And then simplify it. That's what you get. Which arithmetic sequence has a common difference of 4? Arithmetic means you add between terms. So we're going to add 4, add 4, add 4. This is the only choice that does that. The conjugate. The conjugate is an idea. The conjugate of this is the same thing, just with the sign switched in the middle. If sine inverse of 5/8 equals a, the sine of 5, the two sides equals the angle, then the sine of the angle equals those two sides. It's just that concept. How many distinct triangles can be formed if angle A is 35, A is 10, and B is 13? Well, I drew a triangle. And I do the ambiguous case maybe a little bit different than a textbook or any place else you might have learned it. I take a cheap shortcut. I use the law of sines to find how much this other angle is. Okay, if angle B is 48 degrees, then there's an alternative also that angle B could get that works with the law of sines. You do 180 minus 48. 132 is another possible alternative. And if 132 fits in this spot along with this one and leaves enough left over for C, then there are two triangles. If you get another degree amount over here that doesn't fit in, like let's just say we subtracted and we got 150 as a possible alternative, then you could not create two triangles because 150 plus 35 puts you over 180. And if the law of sines doesn't work to begin with, then the answer is 0 triangles. But in this particular case, right, you solve law of sines, you find out that B is approximately 48, that another alternative for B, 180 minus 48 is 132, also works. It leaves me enough left over for C, and so there's two triangles that are possible. When this is subtracted from that, this thing goes in the front. Subtracted from means this one comes first. Distribute the negative, subtract the fractions, find your answer. Piece of cake. The solution set of this inequality is, this is one I use my calculator for. Okay, so here's what we're going to do. First thing we're going to do is we're going to make sure our calculator is in the appropriate window. We got to adjust our window. That means negative 10, 10, 1, negative 10, 10, 1. Okay, it's good. Now, what we're going to do is type in x squared. Sorry, let me clear that out. X squared minus 3x. Now, where do you get this funny looking symbol? You get it by doing second test greater than 10. Okay, we're going to enter it in. Now, this is the solution set. So check it out. X has to be less than negative 2. And x has to be greater than 5. 1, 2, 3, 4, 5. Yep, right there. If x squared plus 2 equals 6x is solved by completing the square, an intermediary step would be. When you're completing the square, it's a whole bunch of steps. It's really easy, though. The first thing you do is you get x's on one side and numbers on the other. So subtract 6x to this side, subtract 2 to the other side. That's what I did. That's how I got this. Now, where did I get this 9 from? When you're completing the square, once you have x's on one side and numbers on the other, like I've done, or constants on the other, then the next step is to take this number, b, Divide it by 2 and square it. So negative 6 divided by 2 is negative 3. And negative 3 squared is 9. This is a perfect square. This factored is x minus 3 squared. And negative 2 plus 9 is 7. That's how I got that. Probability, right? 3 marbles are to be drawn at random without replacement from a bag containing 15 marbles, 10 blue marbles, and 5 white marbles. So I got 30 altogether. Which expression can be used to calculate the probability of drawing 2 red marbles and 1 white marble from the bag? So, because the multiple choice answers have P's and C's, you need to ask yourself, does order matter when you are pulling these marbles out? Does order matter? Is red, white, red the same as red, white, red, even though you might have pulled 2 different kinds of red marbles out? They are not different. Therefore, order does not matter. And so it's a combination problem. Because pulling red marbles, because each time you reach into the bag, it's an independent event. Whenever you have independent events happening within the same problem, you multiply. That's how we get the top. This is the total number of ways that you could pull. You could pull 2 red marbles and 1 white marble. 30C3, that's the total number of ways you could pull 3 marbles from 30 total. All right, so that's why I chose choice 1. 18. All right, so here we go. Anytime you got rational exponents, the top number is the exponent, the bottom number is the index. This guy is a negative exponent, which means in order to make it positive, you have to just show the reciprocal. The reciprocal of this is the positive version. Okay, so this is the same thing as 1 over x to the 2/5. That converted into like a radical form. 5 the index, that goes right there. 2 the exponent goes right there in its exponential spot. So it's choice 4. On January 1st, shares of a certain stock cost $180. Each month thereafter, the cost of the share of this stock decreased by 1/3. What I did was I used my calculator. I tried to take a look at what some of the prices of this stock would look like. And I said, well, okay, if it decreases by 1/3, then it's actually only worth 2/3 as much. And so I did this a few times. You know what I'm saying? Like that. Found a few of the numbers and then tried to pick out which one of these choices had the best ones. And so it's choice 3. Or had the ones that corresponded. Diagram below, we got a triangle, JMT is 90 degrees, and we fill it in. Okay. What's the value of the cotangent of J? Well, cotangent is the reciprocal of tan, which means it is adjacent over opposite. The problem is that you don't know the opposite side, but it's a right triangle, and you can use Pythagorean theorem. That's what I did. You simplify it, you get that. Okay. And so then, therefore, like plugging that in, the adjacent side is worth 6, and the opposite side is worth 6. We're at 3. Reduce. You're left with this. But you can't have a radical in the denominator, so you have to rationalize it by multiplying it by itself, top and bottom. You get that. First one. For which equation does the sum of the roots equal -3 and the product equal 2? Okay, so this is a formula. The sum of the roots is -b over a. The product is c over a. The first number is a, the second number is b, the third number is c. Just plug that in, find out which one makes the sum equal to -3 and the product equal to 2. Use your calc. 22, the expression, this is equivalent to, you got to rationalize it. You got to multiply top and bottom by the bottom. Get rid of that radical. And so I got to this step and I was like, you know what? I don't see any of these choices. That's messed up. Turns out you can factor this. Look at that. They both have 2 in common right there. It's GCF. Cancel. You're left with that. Which equation is sketched in the diagram below? Well, this one, you just use your calculator. Check this out. Okay, so here's what we're going to do. First, we make sure we're in radian mode because that's what these are given in. You could also use degree mode. Doesn't really make a difference. Next, we're going to go to our window. X min, negative pi. Max, pi. We're going to be scaling it by pi. Look at that. That's what each, like, literally hash marker is worth. And we're not going to touch our y mins and y maxes for the time being. You know, I mean, it's bound between -1 and 1, but we need more room to look at the graphs. Now here's what we're going to do. We are going to go into the y equals screen, and we're going to try and plug these in and find out which one looks like the graph that they gave a picture of. Cosecant, so the reciprocals, here's how I remember it. The way you remember it could be very different, but this is how I do it. No two cos go together. No two cos go together. So cosecant must go with sine. No two cos go together. It's got to go with sine. So that's the same thing as 1 divided by the sine of x. And it was just choice 1. We got lucky. Choice 1 fit our graph. Logs, cheap, fast way to take care of logs. When you have a log with a base, right, your calculator, if you look at it and you try and use it, let me clear it out, hit that log button, it doesn't give you the option to put the base in. So here's a cheap shortcut. When you have this, just split it up. This is the log of 1 over 25 divided by the log of 5. Really comes from a change of base formula, but this is an easy way to use your calculator for almost every kind of log problem. Just plug that in, you get -2. All right. This one I did my own little creative way. A 4-digit serial number, so that's why I drew 4 dashes, is to be created from digits 0 through 9. That's 10 choices right there, 0 through 9. How many of these serial numbers can be created if 0 cannot be the first digit? That means you only got 9 choices for the first spot because 0 can't be one of them. No digit can be repeated. So once you choose a number, each one of these should have 1 less. And the last digit's got to be 5. All right. Well, you know what? I started with this last part. The last digit has to be 5 because that means there is only 1 choice for that last spot. And it also means that each one of these is dropped down by 1 because we made 1 choice. Okay, so now I jump back to that first spot. Okay, so the first spot, well, the first spot only actually has 8 choices because 0 can't be the first digit. 5 was already chosen, 0 can't be the first digit. That means there's 8 choices. And I said, okay, so for this instance, I'll let 1 be that. I'm going to choose 1 for that first spot. And if I choose 1 for that first spot, that means for the second spot right here, 5 has been chosen, 1 has been chosen. That means that there are 8 choices left. 0's okay now. That's why this is not a 7, it's an 8. And so I said, okay, so like let's choose 0 for this spot right here. That gives me, for the last and final spot, 7 choices, right? 0's been taken, 1's been taken, and 5's been taken. That means that there are 7 other choices left. And all you do is multiply these numbers across. It's like a pants, socks, shoes types problems where you try and figure out like all the different combinations that you could create, and you get 448. 26. Which equation represents the circle shown in the graph that passes through that point? Well, circles come in this equation. Circles are all points that are equidistant from a center point. Okay, so we got to know the radius. H and K are the center. Just take these numbers and fill them in for H and K, right? And like -4, that's why I got a +4 right there. We got to figure out how much R is. So what I did was I took a cheap shortcut. I said, okay, so I need to know the distance away this point is from that one. And the only reason I chose this point is because they told me it existed. Distance is calculated using Pythagorean theorem. So I counted on my grid how far to the left this was, and then how far down it was, and see how it produces a right triangle? You can always do this. Right? Use Pythagorean theorem, 3 squared plus 3 squared equals r squared, or the hypotenuse squared. Solve it, you get r squared equals 18. Plug it in right there, you're good. Choice 2. Which task is not a component of an observational study? The researcher, so the researcher decides who will make up the sample. No, that when you are doing an observational study, it's the researcher. I'm sorry. Which is not a component of an observational study. The researcher decides who makes up the sample. Yeah, no, you can do that. The researcher analyzes data received from the sample. Yep. The researcher gathers data from the sample using surveys or taking measurements. Yep, that's observational. You're observing, right? The researcher divides the sample into 2 groups, with one group acting as a control. No. This is an example of how you would do what's called an experiment. Okay? An observational study, you are just looking and observing. Okay? You can decide who you are looking and observing, right? But you can't actually touch them. And that's what this is doing. This is a no-no. All right, 28. Solve algebraically for x. Well, here's the deal, right? You need to give these guys the same base. And luckily for you, 16 and 64 can be expressed as a power of 4. 16 is 4 squared, 64 is 4 cubed. Take these exponents, multiply them by this. This is a law of exponents type deal, right? They multiply in. 2 times 2x is 4x, 2 times 3 is 6. 3 times x is 3x, 3 times 2 is 6. Now the only way that this could be equal to each other is if the tops are equal. Solve that equation, you get x equals 0, that's the answer. Find to the nearest tenth of a degree the angle whose measure is 2.5 radians. To convert from radians to degrees, all you have to do is multiply by 180 over pi. That gives you 450 over pi. Plug that into your calculator, just literally 450 divided by pi. You get 143.2. For the given set of rectangles, the length is inversely proportional to the width. If you see this inversely proportional type business, you see these words, it means use this formula. Y equals kx. That's one of those things you got to know. Okay, so then here's what they do. In one of these rectangles, the length is 12 and the width is 6. They tell this to you because what they want you to do is take these, plug them into this equation, right? I just said y equals the width and x equals the length. Plug these in and solve for k, what the constant of proportionality. Because once you know k, you can solve the second scenario where you only know one of the sides. It's got to fit into this formula, but you know k and you know one of the sides, so 72 divided by 9 is 8, and that's the other side. All right, 31. This is a sequence and series type problem. Here's what you do. You see this symbol right here? It means add up. Starting at 1, sub into this equation. 1, and go all the way up to this number. 2, 3, 4, 5. Add all of these together, and then whatever else is out here, 10, 230. The graph below represents this function, and they're going to ask you about the domain and range. The domain is where the function exists from left to right. This function exists from -5 to 8, and it's a hard bracket because these are closed circles. And it exists from -3 to 2 up and down. That's what the range means, up and down. These are also filled in. There's no holes. Here's the trick to 33. 33. A lot of people wanted to try and like simplify the top and simplify the bottom separately. No, that's where you're going to get caught. Combine them. When you have two radicals over each other like this, you can combine them into a big radical. And then this is a fraction that will simplify. 180 divided by 6 is 18. You know, x to the 5th divided by x is x to the 4th. This is y cubed. Break this up, right? Simplify each one of these radicals. Combine what's outside the parentheses together, what's inside the parentheses, what's inside the radicals together. And that's it. You're done. And that's the answer. Ah, a statistics question. Anytime you see the word normally distributed in a problem, use the bell curve. That's what it means it's asking you to do. And the bell curve is located on the reference sheet at the beginning of your test, or the beginning of your green book, the end of the test, when you're taking the Regents. So here we go. The normally distributed with a mean of 19 years. The mean goes dead center in the middle of the curve. Standard deviation, when you look on the reference table, right, you will see the bell curve has numbers written at the bottom of it. 0.5, 1, 1.5. That's for the standard deviation. So here we go. So it's asking you to find to the nearest integer the percentage of first-year college students who are between the ages of 18 and 20. So 19 goes in the middle. 18 is one standard deviation below. Each standard deviation is worth a year, so it's one standard deviation below. 20 is one above. So if you go on the bell curve and go one below and one above, add up all that area in between. That's the percentage of the teenagers that are between 18 and 20. And it's 68%. That's one of those rules you're also supposed to memorize. Using the bell curve, if you are within one standard deviation from the mean on either direction, you are 68%. If you are within 2, it's 95%, and within 3, it's 99%, right? The famous 68, 95, 99 rule. To the nearest integer, find the percentage of first-year college students who are 20 years or older. So 20 years or older, that means here's 20. We want all the percentage, all the area to the right, because that's everybody that's older than 20. If you look on the chart, right, that's this space right here. You'll see some percentages. Add all of those up. That's the area over here, and it turns out it's like 16%. Starting with sine squared plus cos squared equals 1, derive that formula. Okay, so this is a Pythagorean identity. How do you get this? Well, tangent. Tangent is sine over cosine. And tangent squared is sine squared over cos squared. So I'm just going to divide literally this whole thing, each one of these guys, by cos squared. And check it out. Cos squared over cos squared is 1. 1 over cos squared is secant squared. It just works. It's awesome. Okay, write the binomial expansion as a polynomial in simplest form. So here's what I do. This is, you can find the binomial theorem on your reference sheet. It's a piece of cake. Take this number, that's what you start with. And you're going to do all of these. 5C0, 5C1, 5C2, 5C3, 5C4, 5C5. All the way until this number reaches 5. Then, you take this first term right here, you raise it to the nth power, okay? So 2x to the 5th, okay? And slowly, this power decreases. I always say it trickles over to the right, right? So you start at 5. That's the first term. Then it goes 5, 4, 3, 2, 1, 0. Each time. 2x to the 4th, 2x to the 3rd, 2x squared, 2x to the 1st, 2x to the 0. This number over here, this whole thing, raise it to the r power, okay? 0, 1, 2, 3, 4, 5. See the pattern? That's all it is. And then all you do is use your calculator. Find all these. Calculate how much each one of these guys are, right? 2x to the 5th, that's like 2 to the 5th, x to the 5th, 32x to the 5th, negative 1 to the 0. Multiply them individually, That's what I do. I mean, this is my method of keeping track of stuff. And then just put them back in order. And that's an easy way to expand this thing without literally foiling 5 separate times. I mean, that would be crazy. This guy. All right. So in triangle ABC, you've got these measurements. Angle A is 32, A is 12, B is 10. Find the measures of the missing angles and side of ABC. So first thing I'm going to do is, I don't have enough information to just use the law of cosines and find this last side. To do so, I would need angle C. So I'm going to use law of sines and try and figure out, oh, I don't know, like this angle up over here, right? Because I can do that. A is to the sine of A, B is to the sine of B. Cross multiply, you know, you get 10 sine 32 equals 12 sine B, divide by 12. You get this. Inverse it to find B. B is approximately 26.2. Why did I round? Because it says in italics that it wants the nearest tenth. Okay, if B is 26.2 and I know how much A is, then all I have to do is subtract them from 180. I know how much C is. C is 121.8. And once I know C, then I could use the law of cosines to find side C. You just plug into the law of cosines. By the way, these two formulas are on your reference table. Plug into the law of cosines. C is 19.2. The probability that Stormville Sluggers will win a baseball game is 2/3. Determine the probability to the nearest thousandth that the Stormville Sluggers will win at least 6 of their next 8 games. So here's the deal. Whenever I do these types of probability problems, I write out N, R, P, and Q. N is the number of events, total, that's 8. R is what we want. We want at least them to win at least 6. That means we could win 6, 7, or 8. The probability of P of winning an individual event is 2/3, they told us. And if the probability of winning is 2/3, the probability of losing must be 1/3. These always add up to be 1. And so then you have to go through the method of calculating each of these R scenarios exactly, right? And so that's what I did, right? NCR, P to the R, Q to the R, Q to the N minus R is the probability of exactly for any event. You have to do this for each one of these cases. Use your calculator, find out how much each one of them is, add them all together, you get 0.468. That's the answer. Finally, our logarithm question. Okay, this is a natural logarithm. So, temperature T of a given hot chocolate after it's been cooling for T minutes can best be modeled by the function below, where TO is the temperature of the room and K is some constant. Okay, so they gave us some formula right here. A cup of hot chocolate is placed in a room that has a temperature of 68. So this is what I'm doing. There's a lot of variables here, and I'm just going to fill out. What do I know? What don't I know? What are they asking for? Temperature of the room. Temperature of the room. TO is the temperature of the room. So TO is 68. Little t, time, 3 minutes. That's what that is. And the hot chocolate itself, big T, that's 150. Compute the value of K. Okay, so this, and this were given to me in this wording. I got to find K. I'm just going to plug it all into my equation right here. Right? So 150 minus 68, that's 82. You know, simplifying, I subtract 4.718 to this side. I divide both sides by -3. I'm going to make my calculation at the end because this is an irrational number. When you plug this into your calculator, ln 82 minus 4.718, hit enter, divide that by -3, you get approximately 0.104. Nice, that's part A. Part B, using this value for K that you found in part A, find the temperature T of this cup of hot chocolate after it's been sitting in the room for 10 minutes. So now we got to rewrite all our variables again, right? We got to find T, the temperature of the hot chocolate. Well, the room temperature didn't change. It's still 68 degrees. Little t's changed, right? It's been sitting out now for 10 minutes. And we know how much k is. K is 0.04. So plug all that in. Plug it all in. Now here's the problem, right? T is locked up inside this natural logarithm parentheses. So here's the trick, and here's really why this problem is a last problem on your Regents and worth so many points. ln is the same thing as log with a base of e. So transform this back into log with a base of e. Once it's in this form, transform from logarithmic form back to exponential form, right? Base raised to the exponent equals the result. E raised to the 3.678 equals t minus 68. Add 68 to both sides. Plug this into your calculator, you're going to get approximately 108. And that's it. That's the whole Regents.